Okay, 6B. This was 16 was the first one that people left, and so it said find the mean, median, and range. Range is simply the max minus the min, and the maximum was, as you can see on here, is 879 minus 0, so the range is 8.79. The mean is just add them up and divide by, there are 6 of them, divide by 6. And the median is the middle number. And I could sort these, but I'm going to get this by stat. Calculate the one variable statistics on list 1. And it says the mean, if you added them up and divide by 6, you should get 6.275. The median is 7.19. That was the middle number, halfway between the two numbers in the middle. And so the minimum was 0. Q1 was 6. That's the median of the lower half. The median of the whole thing is 7.19. Q3 is 8.48, and the max is 8.79. Let's just kind of point out how the calculator got these. So I'm going to go quit and list math, operations, sort ascending, list 1. Now I'm going to go back and look at list 1. Now they're ascending, the minimum, and there's 1, 2, 3, 4, 5, 6. So if I added 6.25 and 8.13 and divide by 2, I should get the median of 7.19. That's the middle two. It's got to go halfway between them. The lower quartile is the middle of these 3, which is 6. Upper quartile is the middle of these 3, which is 8.48, and the max is 8.79. That's what the calculator did on those. And for the non-coastal is the other list, so I'm going to say quit, stat, calculate the one variable statistics on list 2, and it says the mean for the non-coastal is 6.128 with and then the Tukey 5-number summary is 0, 6.28, 6.98, 8.26, and 8.27. So I notice all these are a little bit less than the other ones. And the median was 6.98, and the range 8.27 minus 0 is 8.27. And now it said calculate the standard deviation. Now I'll do it the longhand, or kind of longhand, on the calculator. I'll do it for list 1. So list 1, I'm going to do it in list 3. I'm going to say it's, to do that I have to go parenthesis, take every value in list 1, so list 1, minus the mean, and the mean was 6.275, and square them. Then I need to add all those numbers up. So I'm going to quit and go to list and get the sum of list 3. That's where I put those squares, and that's 54.08. And then I'm going to divide it by n minus 1, so there's 6, so I'm going to divide by 5, and I get 10.816, and then I'm going to take the square root of that answer, and I get the standard deviation of 3.288 something. But I didn't have to do all that. Stat, calculate one variable statistics on list 1, and it says the standard deviation for the sample is 3.288, and that's what our formula where we divide by n minus 1 gives us that. So that's the standard deviation. Now the rule of thumb says take the range 8.79 and divide it by 4, and that gives us 2.19, and that's an estimation of the standard deviation. Okay, and then I would do those same calculations for list 2. Stat calculate the one variable statistics on list 2, and the standard deviation is 3.1, and the rule of thumb says 8.27. That's the max minus the min, is, since the min was 0, is 8.27 divided by 4 is 2.05 something, 2.0 almost 7, and they're sort of close. That's the rule of thumb standard deviation and the standard deviation. Now if I use the rule of thumb for the standard deviation, where n is less than 15, the other one I gave you, we divide by the square root of n, just to show you that that might be better. Clear this. So let's take the first one, 8.79 divided by the square root, since it's under 15, there's only 6 of them, square root of 6. You notice that gives us a better estimation of the standard deviation, and the other one was 8.27. Still 6 of them, so divide by the square root of 6, and I get 3.37, which is closer than that was. So the alternate rule of thumb that I gave you is a better rule of thumb. Now on 16 we were supposed to then make let's see, what were we supposed to do? Make a box plot. Oh, we were supposed to draw a box plot based on these. So I will put those both on one graph. So I'm going to have to slide this up, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. First thing you want to do is make a scale that's nice and even. Don't matter what the vertical scale is. And then for the coastal, we're going to have the middle is at 7.19, and then we're going to have 6 and 8.48. 6 and 8.48. That's our interquartile. Our max is 8.779, and our min is 8.79, and our min is 0. That would be the one. The other one has median of 6.98. 6.98, not very far different. And lower quartile 6.28, upper quartile of 8.26, and max of 8.27, and min of 0. So the non-coastal is a little less spread out, except for the outlier. but you can see that the interquartile range is a little squeezed tighter together, so there's less variation on the non-coastal taxes versus the coastal. Pretty much the same average tax rate. That's what they wanted you to kind of get to. And that's pretty much what they want you to do on 18. So I don't know that I necessarily need to do those. Actually, 18, I will make the box plots on that because you'll notice stat, edit, that I put in list 4 the times for Beethoven symphonies and list 5 for the Mahler symphonies. So let's do second stat plot, just so you know how to do the stat plots. I'm going to turn on plot number 1, and I'm going to make a box and whisker plot. Whoops. Using list 4. Yes. And then I'm going to go stat plot, turn on 2, I'm going to make it be a box and whisker plot using list 5. And then I'm going to, doesn't say 1's on. Go to y equals, yes, it is on. So clear that equation, and I'm going to go zoom. Stat plot is 9, zoom stat. And it picked this kind of a strange scale here. So window. Let's go from x min to x max is 100. Let's make it 0 to 100. And the y min and max doesn't really matter for this because there's no vertical scale. Let's do every 10 units and graph. And it shows, for some reason we've got something wrong here. I've got one of the wrong lists here. Stat, edit. One of them's in list 4 and one's in list 5. I must not have gotten list 4 correct. Oh, yeah, it says plot 1 is list 1. I want to get list 4 in there. So enter list 4. Now graph. There we go. Okay, so now if I traced, I can get the median, the lower quartile, and the minimum. Minimum is 26, lower quartile 29, 36, 45, and 68 for Beethoven's. And if I arrow down, I'll get on the other box plot, and I'll get the minimum is 50, 62, 80, 87.5, and 94. Those are the two key 5-number summaries, and you can see clearly that there's about the same amount of distribution, although the centers, Beethoven symphonies, were all closer together and closer to, let's see what that was, closer to the 36-40 minute time frame. And on the Mahler, the middle is about 80. So Mahler symphonies are significantly longer. They vary both about the same, although there's more variation in the center values of Mahler's than in the other one. So that's kind of what they were trying to get you to look at. And I can figure out the standard deviations of these and all the other stuff by going stat, just so you can see them. Calculate, and I can do list 2 variable statistics, and I can say on list 4, comma list 5. I didn't show this in class, so I can do both of these together. So there's the mean of list one of them. Yes, this is list 4. There's the mean, and the standard deviation is 13. And there's 9 data points, and y is 75 with a standard deviation of 15. So they're similar standard deviations. And here's the minimum x, maximum x, and minimum y and maximum y. It doesn't give you the 5-number summary when I do this, but you can see those. So there is those numbers in case you wanted to see those. Okay.